Hello. Um, Over the last couple of years, an increasing number of offshore vessels have been installed with battery systems on board to meet the demand from the industry and the demand from environmental impact. This trend has also reached the fleet of drilling rigs. So, Arne, could you tell me what can an electric storage be used for on an offshore unit?
Well, Sverre, while batteries have been used on board ships and rigs for many years, new potential is seen and new challenges have been found with the introduction of the lithium-ion battery systems. Electrical energy storage systems based on lithium-ion technology have some clear advantages. Depending on the application, the energy density can be high, the power output can also be very high, and these systems generally also handle cyclic loads well. On dynamically positioned units or DP vessels, a correctly sized electric energy storage system can replace a running diesel engine as a so-called spinning reserve. Energy storage systems are also well suited for peak shaving. On drilling units, the energy storage system can receive and reuse electrically generated energy in heave compensation or tripping operations. We've also seen electrical energy storage systems used for crane operations. Experience has shown that electrical energy storage systems can reduce emissions and running hours from fossil fuel engines. In many instances, the reductions are significant. However, energy storage systems will not be ideal for every type of installation. But Sverre, what are the challenges with installing electrical energy systems based on lithium-ion technology?
Yeah, well, Arne, as you probably also know, there is a challenge with respect to fire and explosion risk when you use lithium-ion batteries. As you know, the electrolyte inside these fantastic batteries, they are made of a flammable liquid. So it's very important that you installed it in the correct manner so that if this liquid is coming out, you will not get an explosion risk and also don't get a fire risk. So ventilation and all this stuff need to be in place. It is also important because if I want to use the battery, I need to know how much capacity I have on the batteries. And by that, I need a system, an energy management system, for instance, to measure this or present this available energy, for instance. And of course, a battery is, as you and me, have a limited lifetime. So you need, in a way, to condition it so that it lasts the longest, so you get most payback for your money.
Okay, but what has the industry and more specifically DNVGL done to meet these challenges with the new lithium-ion battery systems?
Yes, it's actually we have done a lot in the industry and in DNVGL. So first of all, we have learned a lot. These batteries was introduced to the maritime market back in 2010, 2011, and so on. And there has been a lot of learnings since that. In 2012, DNVGL make the first set of rules for battery installation on board vessels and rigs, and have continued this development as the learnings have been better, and there has also been some incidents. We do certify batteries, and that's important so that you have a safe battery that you put in, so you don't make your installation less safe. And of course, we are working very closely to the industry. So, for instance, I would like to name this joint development project, this technical reference for explosion and fire risks on board vessels that we have done together with battery makers, some ship owners, and also some administrations have been involved. And this is looking in and simulate what can go wrong and what is the smart measures to do. So there is a lot of ongoing thing, and it's actually very interesting. But you, Arne, as a surveyor, what challenges do you see? You are on board this vessel when this energy storage system are installed.
Well, Sverre, as you know, the offshore new building market has more or less dried up. The trend on ships, rigs, and offshore installations is to retrofit electrical energy storage systems. And I've been involved in several retrofit projects. As the units were not designed to have the energy storage systems on board, there are several challenges that are additional to the challenges found with the normal installation of an energy storage system in a new building yard, and there are enough challenges there. For the retrofits, where should the energy storage systems be installed? In containers on open decks or inside the unit? There are challenges with both options. How can the energy storage systems be optimally interfaced with the existing power grid? Is it possible to meet all the requirements in the risk assessment to ensure a safe installation with regards to fire protection, explosion risk of impact, ventilation, etc.? Through an onboard installation survey, DNV GL verifies the installation against approved documentation, rules and regulations, and witnessed required testing. Our experience from the projects we have been involved in has been that the close cooperation between the owner, designer, and DNV GL from the early stages of a project gives the best results, not only ensuring a cost and time-efficient installation that meets requirements. An open discussion reduces the chance of misunderstandings and expensive but unnecessary solutions. After all, we are in the business of safeguarding life, property, and the environment.
Yes, very interesting, Arne. I just want to sum up what we have talked about, and in short, you can see that as long as your design and installation are correct for energy storage system, you will meet the industries and the environmental demands without any increased risk or increased lifetime cost. So, by that, thank you for listening in. And if you have further any questions, please contact your local contact in DNV GL.